All right, so today in Algebra 2, we are starting Chapter 5, Section 5.1, Nth roots, radicals, and rational exponents. Our essential question for this chapter: how are rational exponents and radical equations used to solve real-world problems? Our essential question for this section: how are exponents and radicals used to represent roots of real numbers? And after today, you should be able to relate roots and rational exponents and use them to simplify expressions and solve equations. So let's start out with some vocabulary. Okay? So an nth root of a number, so this is an nth root of a number, is c, okay, is x. Okay, so an nth root of a number c is x, such that x to the n power equals c. An nth root can be noted by a radical symbol. So this is a radical symbol with an index of n. So then here we see that this n, that's our index. Our index tells us what root we are taking. Okay, we have the radical symbol, and then the c, okay, whatever's underneath the radical symbol, is called the radicand. A lot of this vocabulary is review from Algebra 1, geometry, lots of our earlier math classes. All right. So the number of real roots is going to depend on the degree of the equation. Okay? If you have an odd degree, so if you have like a cubed root, a fifth root, a seventh root, a ninth root, so your n is an odd number, you will have an odd number of real roots. Okay? If you have an even degree, so if you're looking at a square root, a fourth root, a sixth root, you will have an even number of real roots. So we're going to look at example number 1, find all the real cube roots of 125. So we're going to look at really what this is asking us is what value of x so that x cubed is 125. We can change this to a radical, right? So if I change it to radical, it's saying x equals the cubed root of 125. There's lots of different ways that we can look at this, okay? If I do factor tree, okay, so factor tree, just like I'm going to break it down. So what can I multiply together to get 125? That's 5 and 25. 25 becomes 5 and 5. Now, up to this point, you've done factor tree and you've taken pairs out, right? Buddies. Okay, that's because you were always doing factor tree on square roots. So here I have a root of 3. Therefore, when I do factor tree, I need 3 alike to come out. Okay? So whatever your index is, that's how many make up your buddies or your pairs that are going to come out. So since I'm doing the cubed root, I would need 3 numbers, all of the same in order to come out. 3 5s, nothing left behind. So here x is equal to 5. So the cubed root of 125 is equal to 5. Notice I have one answer. The number 1 is odd. Up here we said odd degree, odd number of real roots. So I was taking the cubed root, that's an odd number. I should have an odd number of answers. So I only have one answer. Another way, if I did not want to do factor tree, I could have actually factored it, right? So if I look at x cubed equals 125, and I want to solve that, so subtract 125, bring that over, I get x cubed minus 125 equals 0. This is a difference of cubes. We've learned how to factor that. So this would factor to the cube root of x cubed, which is x. Keep my sign minus the cube root of 125, 5. Second set of parentheses. My first one's squared, so x squared. Change my sign. Multiply the 2 together, 5x. And then square the last one, plus 25. So when I solve this, here I get x equals 5. This x squared plus 5x plus 25. Okay. Remember when we looked at the discriminant, okay, the b squared minus 4ac will tell me how many roots I have and what kind they are. So if I did this, I would get 5 squared minus 4 times 1 times 25. This is going to be negative, therefore no real roots out of this one. That's why x equals 5 is my only answer. So I'm just showing you several different ways that you can work these. Okay. Again, I don't care which method you go with, if you set it equal to 0 and factor using our identities, or if you do factor tree. So number 2, what are all the real fourth roots of 16? So notice that I'm looking for fourth roots. That's an even number, so I should have an even number of answers. Okay. So again, I'll do this one both ways for you. The fourth root of 16. So if I do factor tree, 16 came from 4 and 4. 4 breaks down to 2 and 2, 2 and 2. This time, my index is 4, so I need the same number to repeat itself 4 times in order to come out. So all of these come out as a 2, okay? So I would get x equals, but I have to remember that since it's an even root, I have 2 answers, both the positive and the negative. So this is x is positive or negative 2, okay? Or if I looked at x to the fourth, because this is x to the fourth equals 16, okay? I put the radical in the problem, so therefore I'm going to have the 2 answers, positive and negative. Okay? I could factor it, say x to the fourth minus 16 equals 0. This is a difference of squares. This factors to x squared plus 4, x squared minus 4. X squared minus 4 is another difference of squares, so my x squared plus 4, x plus 2, x minus 2 equals 0. So right here I get x equals negative 2 and positive 2. Same thing as I got over here. If I did factor tree, x squared plus 4, that would give me imaginary or complex answers when I solve that, and we're only looking for the real ones. Okay, so again, I just need to remember that if I'm looking for an even root, then I'm going to have positive and negative. I'm going to have those 2 answers. So number 3, find the real fourth roots of 81. Okay, so I'm looking for x to the fourth equals 81. Again, I could do it either way. I'm going to go ahead and just factor this one. So x to the fourth minus 81 equals 0. So that's a difference of squares. So that's going to factor to x squared minus 9 and x squared plus 9. X squared minus 9, that's another difference of squares. So that's going to factor to x plus 3. X minus 3, and then my x squared plus 9 stays the same. So each of these equal to 0. I get x equals negative 3, x equals positive 3. This one is going to give me imaginary numbers. So my 2 answers, positive and negative 3. Number 4, find the real cube roots of 64. So I'm looking for cube. That's an odd number, so I'm going to have an odd number of answers. So I only have one answer here. So x cubed equals 64. That's what I'm looking for. Again, I could factor it. So x cubed minus 64 equals 0. This is a difference of cubes. So the cube root of the first one, x, minus the cube root of 64 is 4. And then x squared plus 4x plus 16 equals 0. So I get x equals 4 from the first one. Again, this one, if I looked at the discriminant, I'm going to get imaginary. So my only answer, x equals 4. All right, next page. Understanding rational exponents. So for every positive integer n, x to the 1 over n is defined to be the nth root of x. Rewrite each fractional exponent using the properties of exponents to explain what their fractional exponent means and then evaluate it. So 16 to the 1/4 power. This is asking me what number, okay? What number can I raise to the 4th power to get 16? Okay, that's what this is asking me. If I were to rewrite this, okay, that 4, that's in the denominator, so that becomes my root, my index, 4th root of 16. Okay. So again, I could do factor tree. So 16 is 4 and 4. 4 is 2 and 2. 2 and 2. Again, it's a 4th root, so I need 4 to be the same. So here my answer is 2. So 16 to the 1/4 power is equal to positive 2. Here I only have one answer. I only have the positive answer because we did not put the even root into the problem. They were asking me 16 to the 1/4 is equal to what? Okay. Right. Number 2, 27 to the 2/3 power. I can rewrite this. as this bottom number, okay, is my index. So the cubed root of 27 squared, or I can say this is the cubed root of 27 and then square my answer. Okay. It doesn't matter which one of these I work out. Okay, if I square the number, then take the cubed root of it, or if I take the cubed root and then square it. So I do the cubed root. Okay, what's the cubed root of 27? What number can I multiply by itself? 3 times to get 27. That's 3. So this is 3, and then I square that. So 3 squared is 9. So my answer is 9. So 27 to the 2/3 power is equal to 9. Number 3, 25 to the 1/2 power. Okay, so here it's just the square root of 25. The square root of 25 is just 5. And again, it's only the one answer, positive 5, because I didn't put the square in the problem. They had already given it to me as 25 to the 1/2 power. Okay. Number 4, 32 to the 2/5. So that would be the 5th root of 32. And then I'm going to square that. So the 5th root of 32. So if you don't know what one number you can multiply by itself 5 times to get 32, we can always do factor tree. So 32 came from 8 and 4. 8 breaks down to 2 and 4. 4, 2 and 2. 4, 2 and 2. This time it's the 5th root, so I need 5 numbers to be the same to come outside. So I have 1, 2, 3, 4, 5 2's. So this turns into 2, but then I have to square it. 2 squared is 4. So 32 to the 2/5 power is equal to 4. Okay. Now we're going to look at interpreting fractional exponents. The index of a radical is equivalent to the denominator of a fractional exponent. We just looked at that. If the nth root of c is a real number, so the nth root of c is equal to c to the 1/n power. If m is an integer and m divided by n is in lowest terms, then c to the m/n power is equal to c to the 1/n, all of that to the m power, or the nth root of c to the m, or c to the m raised to the 1/n. Okay, so there's just lots of different ways that you can work these out. This is exactly what we were doing up on the previous problems. Okay? So evaluate 32 to the 3/5 power. Okay? So I'll have to rewrite this. Okay? So this is really the same thing as 32 to the 1/5 power cubed. That's what this is saying. So it's the 5th root of 32, and then I'm going to cube that. We just saw earlier that the 5th root of 32 is 2, so then I have to cube that. 2 cubed, 8. 27 to the negative 2/3, so it's the cubed root of 27, all of that to the negative 2 power. So the cubed root of 27, that's 3, so I have 3 to the negative 2 power. But a long time ago, we learned that we can't have negative exponents, so in order to make them positive, we move them to the denominator. So this is really the same thing as 1/3 squared, which is 1/9. 50 to the 3/4 power. So this is the 4th root of 50, and then we're going to cube that. The 4th root of 50, that is not a nice whole number. That's okay. We can use our calculator and we plug that in. So we ask our calculator for the 4th root of 50, and then we're going to cube that number. And when we do, we get approximately 18.8. Okay. Right. So let's look at a word problem. The Fujita scale rating F of a tornado is represented by F equals the cubed root of the quantity W divided by 14.1, all of that squared, and then minus 2, where W is the estimated wind speed of the tornado in miles per hour. What is the Fujita scale rating of a tornado with estimated wind speeds of 100 miles per hour? So in tornadoes, we've heard of like it's an F1, F2, F3, F4, F5. This is where they come up with that. Okay, so they told me estimated wind speed of 100 miles per hour. They tell me W is the wind speed. So we're just going to plug in 100 into that problem. So the cubed root of 100 divided by 14.1, we're going to square that number, and then we're going to subtract 2. Okay. So when I work this out, the cubed root, so 100 divided by 14.1, not a nice whole number, so we're going to just go to 2 decimal places, so 7.09, then I need to square it and subtract 2. So when I work all of that out, I get approximately 1.69. Again, the scale, remember, we don't have a It's a F1.69 tornado. We have it's F1, F2, F3, F4. We do not round up here. So the tornado with estimated wind speeds. Remember, it's a word problem, so we're going to write out our answer of 100 miles per hour is classified as an F1 because I got 1.69 tornado according to the GPS scale, all right? Right. Let's look at a few more of those. So next page. What is the value of each expression? Round to the nearest hundredth if necessary. So exactly like what we've been doing. So here we're going to take -1, multiply it by the 4th root of 16, and then cube this number. So I have -1 times the 4th root of 16. Well, the 4th root of 16 is 2, but I need to cube 2. So 2 cubed is 8. So this is -1 times 8, which is -8. The 5th root of 3.5 to the 4th power, and again, it doesn't matter. I can do the 5th root of 3.5 first and then raise it to the 4th power, or I can do 3.5 to the 4th power and then take the 5th root of that. This is a decimal, so we're not going to get a nice whole number, so we need our calculator for this. So if I type in the 5th root of 3.5, okay, and then I take that and raise it to the 4th power, I get approximately 2.72. Right, that's probably where we will stop for today. So this is day 1 of section 5.1. Your homework will be Envision 5.1. I just put both days of Envision all together. And so today's homework will actually not be due until Wednesday. So, sorry, Thursday, because we'll be doing Tuesday and Wednesday. I'll give you to do all of it. And then Thursday at class time is when the assignment will be done. So if you're going through the Envision assignment and you don't know how to do some of them yet, that's perfectly normal because we have not covered all of this material. After tomorrow's lesson, you should be able to do all of the assignment. Right?